right, everybody. Well, thanks very much for coming. I appreciate it. We're going to get underway here, knowing that at some point they may bring me a proper table on which to perch my laptop. Right now, it's kind of hanging off the side of the podium a little bit, and as I do type when I do my presentations, it's at an odd angle too. So I'm hoping they're going to come swap out the podium for me at some point. OK, so very good. Well, thank you very much for coming. I appreciate that you could be at any of the other excellent talks. I'm grateful to have you here today. We're going to go through a fair amount of stuff today. And so I've put the recipe, the coordinates for the code up there online. Now, I should mention that this talk was originally something that my friend and esteemed colleague, Mark Heckler, and I co-developed. And he got routed to New York temporarily, so he couldn't be here with us today proper, but I think he's going to be here tomorrow. Is that about right? So you should definitely find him and tell him, if you liked the talk, then you should tell him it was a good job and good talk. And if you don't like the talk, then you should definitely tell me instead of him, because that poor guy doesn't deserve that, right? So thanks to Mark Heckler. This is all, once you see some of the ridiculousness in this talk, and if you know Mark Heckler's sense of humor, you'll appreciate that was a lot of it was his brilliance and beauty. So there's that. I'm going to go through a lot of stuff today. I'm at StarbucksMan on Twitter. Mark Heckler is MKHeck, M-K-H-E-C-K on Twitter as well. If you have questions, comments, feedback, good, bad, or otherwise, send it to me. If you have if you have only good feedback, then send it to him. But otherwise, I'm happy to answer questions. I'm on Twitter. How many of you are on Twitter? It's 2017. Twitter. OK, very good. The rest of you, get on Twitter. It's the new IRC. It's a great place to be. It's where all the developers that power the open source that drives the projects on which you work live and exist. What was that? Oh, things are getting weird. So there's that. What about email? How many of you have email? Email. Anybody? No. OK, well, if you do have email, I'm happy to answer questions there as well. Don't hesitate to reach out to me. A little bit about me. My name is Josh Long. I'm a Spring Developer Advocate on the Spring team. I have been an open source contributor and an engineer on the different projects in the Spring ecosystem, not the least of which are things like Spring Boot and Spring Cloud and Spring Batch and Spring Integration, and as well as other sort of ecosystem projects, things like Timeleaf and Activiti and Vaadin and so on. I have the dubious distinction and honor of being the #1 most widely recognized and most visible and most highly rated contributor of bugs, but still #1 contributor of bugs to those projects. More bugs per commit than any other contributor. That's something, right? It's not a great thing, but it is something. So there's that. I'm also a Java champion, and that dovetails very nicely with what I do. Hi. It dovetails very nicely with what I do as a Spring Developer Advocate. Do you want help? Almost lost you.
No, it's going to fall back a little bit.
OK. Here he comes to save the day. Oh, so good. Thank you. We're almost there, my friend. We need it just a wee bit longer. OK, anyway, it dovetails very nicely with what I do as a Spring Developer Advocate. I spend my time trying to help the Java community level up and build bigger, better things on top of the JVM, usually in terms of Spring. As part of that, I've done training videos. I've just finished the latest and greatest edition of this training, the second edition of this training video that I did with my friend, the one, the only, the amazing, the inimitable Phil Webb, the co-founder of Spring Boot. And by the way, I wonder, I think he might maybe be here in the conference somewhere. He might be at the booth. I don't know if he's here this week, but if he is, you should say hi and tell him thanks for Spring Boot. And then I'm working on the, come on. Very good. And then I'm working on wrapping up the first edition of Cloud Native Java, which is a book about how to build applications that survive. Thank you, by the way, so much. Thank you so much. It's a book about how to build applications that survive and thrive in the cloud at scale. And the book is in terms of Spring Boot and Spring Cloud and Cloud Foundry. Now, for those of you wondering, and I can imagine most of you are, I can see it in your eyes, I can see the curiosity welling up in your eyes like a pond. For those of you wondering, that bird is a blue-eared kingfisher. It's a bird that is indigenous to the Java Islands in Indonesia. It's a bird that is, in English we'd say, native to the Java Islands in Indonesia. Now, birds, you see, they do from time to time fly. Now, birds fly, often when it's appropriate, in the clouds. So this is a bird that is native to Java that flies in the clouds. It's a cloud-native Java bird. Never mind, it's fine. It'll come. Give it time. Anyway, moving on. And I work at Pivotal. And at Pivotal, we have a lot of good open source technology. I care about the open source. But let's be very clear. That's not the reason that I or anybody else on the team is here. Ultimately, we serve a goal. We serve a goal, a vision. We want to help customers and community members move safely and quickly to production. As part of that, we've seen a lot of organizations moving to this idea of microservices, to this architecture of microservices. And there are a lot of concerns that become obvious once you introduce and redundancy and distribution into a system, things that aren't obvious in the single node, single instance case. Microservices has a lot of benefits. It gives your organization the ability to scale, to go faster, to evolve software faster, and to decompose larger things into smaller batches of work. But one thing that becomes interesting is that you have now the complexity of distributed systems. And for most of those use cases, you can use things like Spring Cloud to sort of address them. One sort of key use case that isn't well served by the traditional existing stack of microservices support is things that have to do with lots of data, long-lived sort of data processing, anything that has to do with a lot of I/O, right? Input and output. And so for this, we've seen a sort of revolution on the JVM in the last 5 years, a lot of great technology to support reactive I/O, reactive or asynchronous I/O on top of the JVM. And this support builds upon foundations that were introduced in the JDK and 1.4, which in turn builds upon primitives in the kernels and in Windows that have been there for the last 20 years, right? The basis of this is that I/O ultimately is asynchronous in the kernel, right? When you go down to the very lowest levels of the operating system, input and output in the operating system is asynchronous. It's only on the JDK and in these platforms that we force input and output to feel synchronous. But if you can embrace the fact that things are asynchronous, ultimately, essentially asynchronous, and you build your systems accordingly, you get a lot of benefits. So we'll talk about what that means today. But it's important to sort of understand where we are, what the context in which all these things lives is. In the Java community, in the Java ecosystem, there have been several different projects that I think have gotten very, very popular, starting with RxJava. RxJava was a technology for supporting reactive applications and workloads, and that was in turn inspired by the work that was being done by the folks at Microsoft in something called the Rx extensions. That in turn led to a bunch of other sort of approaches to solving similar problems, which in turn led to a sort of de facto standard that was forged by the folks at Pivotal, that's us, the folks at Red Hat on the Vertex project, the folks at Netflix's RxJava project, the folks at, who else? Lightbend or Nay, TypeSafe, Aka's project. All these fine engineering teams got together and decided, okay, well, we need to describe in the simplest way possible the essence of what it means to work with a system that is essentially asynchronous, that produces results on a timescale that we cannot predict. And so they created the Reactive Streams Initiative. And the Reactive Streams Initiative is the basis of what we're going to look at today. So before we get too far down the path and look at the technology in terms of Spring, let's talk about reactive streams and what that looks like for the average consumer. Okay, so we're going to build a very simple application here today. I'm going to do, as I always do, I'm going to go to start.spring.io. This is my second favorite place on the internet. Anybody who knows me knows that I love start.spring.io, but the only place I love more than start.spring.io is production. And if I'm not in production, I begin my journey here at start.spring.io. So what we're going to do is I'm going to build a brand new application. I'm going to use, parallelously, I'm going to use the snapshots of Spring Boot 2.0, which is due at the end of the year, right? So I'm living on the edge here. What I'm going to do is I'm going to use Spring Boot 2.0, which auto-configures Spring 5, the reactive support in Spring 5 in particular. Spring 5 is itself not GA yet. Spring 5 will be released in the summer of this year. So we're looking at snapshots of snapshots, right? In order to build my application, I'm going to build an application. We're going to build a little demo here. And I'm just going to bring in the reactive web support. I'm going to talk about the basics of the Reactive Streams API before we can go too far, because I want to make sure we're on the same page. So we're going to build an application. What's important to understand is that in our interactions with data, we are used to thinking about things synchronously. If you have a single value, and you want to return a single value from a method, right? Let's call that t. You say t, do something, parenthesis, parenthesis. If you want to return multiple values synchronously, you can call that a collection of t, right? You're saying I have a collection of t values that may be there. If you have a value that may be returned asynchronously, right? A single value that may be returned asynchronously, we call that a completable future of t, right? It's a future, but you can get a notification when the value is there. But in the JVM itself, there's no real sort of good story for how we answer the question of multiple values that may be returned asynchronously. So that's one of the problems that the Reactive Streams initiative is aiming to solve, and that's solved in terms of something called the publisher, right, in the Reactive Streams initiative. So if you look at this, we're going to create a very simple example here. I've got a Spring Boot shell around this just because I'm using the initializer, but you don't need anything. You don't need Spring Boot to use the lowest levels of Reactor, right? So Reactor is a separate project. Reactor is our implementation of the Reactive Streams initiative, and it gives us the ability to talk about values that may be delivered asynchronously in terms of something called a publisher. The publisher is a base type in the Reactive Streams API, right? So here's a publisher of string, right? The publisher has one method, subscribe, and passing in a subscriber. Now, this is a very, very basic, type. It doesn't give you the ability to do any kind of interesting things with the data. You just get notified when there's a value. What you need is higher level operators, things that you can use to talk about the incoming data and manipulate them, process them, transform them, map them, do all the things that you might be accustomed to doing in the lower level JDK collections or indeed in Java 8 streams. So in the Reactor world, we have two subtypes of publisher. One is called a mono of whatever. A mono is a publisher that will only ever produce one value. A flux is a publisher that will produce multiple values, potentially unlimited values. It could produce values until eternity, right? It's not going to load all the data in memory. It'll just produce values as long as there's values to be. It could be entropy. It could be stock quotes. It could be, heartbeat events from services. It could be whatever you want, right? The point is, there's no understood bound on this type here. Now, you can use these types pretty easily. Let's say I wanted to create a flux of values, and I can say flux dot from array, right? And here I'm just going to say 1, 2, 3, 4, right? Split that into a bunch of strings. So now I've got a very simple flux that has those values in them, and I can do things with that. I can say, okay, let's turn those values into integers. So I'm going to call integer dot parse int, right? I can also filter them, just like it would with Java 8. I could say, okay, for each I want to take only the I that 1 divided by 2 is equal to 0. That's the prime, right? So I'm going to now collect that. And then what I want to do is I want to take the results and then use them. So I can turn it into a stream, right? I can also subscribe. And here I have a few options here, right? What I want to do is I want to subscribe to the results. And there's my favorite way to call this method is to use the version that takes 3 consumers, one for the values themselves, one in case something an exception is thrown, and then one for a runnable to get run at the very end of the processing. So the value for the consumer itself is this. We say system.out println, okay? And I don't know about you, but let's see, do I have that integer? Yep. I don't know about you, but I never make mistakes, so I won't put an error handler in there. Oh, this is println. I made a mistake. Ha. And then we need a consumer, right? And this is the last parameter. It's a runnable that you can run when all the processing is done, right? In this case, I don't really need it. So there we go, replace with lambda. So that should work. Let's see if that does what we expect. and blue chunks. Oh, well, first of all, pkill Java, thank you. Second of all, this is going to start a web application because I've got the auto configuration running. So let's see what that looks like. There we go, right? So on the console, there it says 2 and 4. So very, very simple. And the benefit here is that by working in terms of publishers, right? This is actually, at the end of the day, this is just a publisher. So if I say publisher, publisher of string p, and then you can say, here we have p equals x. They are the same thing, right? You can work with the publisher type, or you can use the specializations Flux and Mono in the Reactor project. Okay, with that basic understanding out of the way, let's turn to how this applies to us as developers building applications in terms of Spring. So what we're going to do today is we're going to build a new application, a service to manage, fictitious or fictional movies. Let's just create a service to manage movies, and we're going to use the Flux and the Mono and the Reactive APIs in our application. So we're going to call this the Flux Flix service, which is abbreviated as FFS, right? So there's that. In order to do our work, we're going to use Reactive Mongo there as well, because I like losing my data randomly for no reason at all, so I'll use that as well. And we're going to use Lombok, okay? Now, again, I could elect to switch to the full version, and thereupon I'll be given a veritable ocean of checkboxes, but for our purposes, it suffices to leave things as they are. Okay, so here we go. This is a service that works with movies, and it's going to be based on the internet. And movies are all alternatively called a flick or flicks. We could call this the Netflix API. No? No? Huh? Oh. Oh, it's not even a mercy laugh. Okay. Flix service application. Okay, so let's see. We're going to build a Pojo. Can you all see that in the screen? Is that big enough? In the back? It's okay? Yeah, thank you very much. So we're going to create a Pojo. It's going to be a document, a Spring Data MongoDB document. It's going to have a primary key as a type ID. I'll map it to @ID. And then I'm going to create a field here, private string title, and we're going to have another field called genre. And I want to create some getters and setters, so I'll create an all-argument constructor using Lombok, which is a compile-time annotation processor that'll look at the class and it'll automatically add getters and setters. It'll add a toString method if I give it the toString annotation. It'll add a no-argument constructor. It'll add data. It'll add getters and setters as well. So these are all to do things that other languages do for free. This is to tell Spring Data Mongo about the Pojo, about the entity itself, so I don't have to worry about writing all that code myself. And then in order to be able to work with this data, this entity, I want to create a repository. And again, this should seem very familiar to anybody who's used Spring Data. How many of you have used Spring Data? Okay, so ultimately, at the end of the day, Spring Data is an umbrella project that supports a lot of different technologies. Reactive Mongo repository. Reactive Mongo repository. We cannot make all of the different technologies out there reactive, right? We want to support reactivity wherever it's appropriate, but some things are intrinsically synchronous. JDBC, for the moment, although Oracle spoke about perhaps introducing a reactive API at the last Java 1, so that's, knock on wood. But in the meantime, there are some APIs that support very capably a full reactive experience, including MongoDB, and that's already auto-configured for us here. Spring Data at the moment has preliminary support for reactive Couchbase, for MongoDB, for Cassandra. I think I may be missing something, but as it's possible, we're supporting that in the projects. So now I've got a Reactive Mongo repository, and what I want to do, my friends, is I want to write some records to the database so that we have some sample records with which to work. So what I'm going to do is I'm going to create a bean of type command line runner, and now the command line runner is just a callback interface in Spring Boot. When Spring Boot starts up, it's going to call this command line runner and pass in, or rather, it's going to call this the void run method, which the command line runner provides, and it's going to pass in the public static void main string argument array here. In order to do the work, I'm going to inject my repository. There we go. I'll create some sample records here. And so here, my friends, I encourage audience participation because I can't have all the fun. What I want to do is I'm going to write some records to the database that write some titles, movie titles to the database. And we're going to just riff on the theme of reactivity and fluxes and monos and so on. So let's think about this. Aeon Flux, no, anybody? That's a real movie. Enter the mono void, get it? Okay. The fluxinator, silence of the lamb does. That's my friend Phil Webb's. That's my favorite. Yes, sir?
Reactive mangos on a plane.
Reactive mangoes on a plane. Mark had a great one, Y tu mono también. There's a movie called Y tu mama también, but mono in Spanish means monkey, so that's kind of fun. Any others?
Attack of fluxes.
Yes, Attack of the Fluxes. The Fluxes? I don't know what the plural of flux is, but if a single devox is just DEVOX or something, I don't know. Maybe it's 3 X's, I don't know. So anyway, anything else? No? Back to, what? Yeah, Back to the Future, right? Back to the Future. Thank you, sir. And what we're going to do is we're going to visit each one of those, and we're going to create, from those names, we're going to create a movie. And the movie expects as its parameter a UUID, so we're going to give it an ID there. It's going to expect the title, there's the name, and it's going to expect a genre. And so I'm just going to give it a random genre because it's just fun to see what gets matched up to what. And we're going to create a little method here. I'll have a string array of genres, okay? And I'll say horror, rom-com, drama, action, documentary, and we'll just split that up, okay? And I'm going to say new random dot next int, using the inclusive bounds of that array there as the parameter there. So genre, indexing into that, very good. That'll give us our genre, and then for each one of those, I just want to write the records to the database. Actually, I'll just do a map again. And so here, I'm going to say movie repository dot save movie. Okay, and that, in turn, should do it. No, we want there one more thing, don't we? For each. Flat map. Could be good. What did we get there? So we have a map. Whatever, let's just call subscribe. Or for each, even better. There we go, we'll just print out the results. Okay. This can be a lambda. Okay. Oh, port binding conflict again, naturally. So, kill the existing Java app, pkill Java, that's your friend. Restart. There we are. Oops. Okay. Did I want to do that? Okay. Print out something more meaningful here. We want to get the. Could have sworn we just did this. What did we do there, James? Yeah, we just did this. There was a subscribe in there, my friend. Okay, well, whatever. We can do it the hard way. We say movie repository dot save, passing in m dot subscribe. Maybe that one.
Try the subscribe after the map.
We just did that. That's the one that was. Oh, after this one. For each. Okay, restart. Now we're cooking. So there we go. So we got the records written to the database, and I've gotten the results coming back. This is a database that's already, it's already existing, so we need to make sure that we clear everything. So I'm going to go ahead and say delete all. And what I can do then is I can subscribe to the results. And what I want to do is when the result comes back, I want to call this method and write the records to the database. So I only want to write data after everything is done, right? So after the deletion has happened, and I don't need the other parameters here. So the other parameter would be for the throwable. Don't need that. Don't need the runnable. I'm just going to do everything at the very end of the line there. Complete? Oh yeah, okay, we'll do that in the runnable. Okay, so we want that as a null. Put that in the runnable. That didn't work. It's a runnable. Okay. Whew. There we go. So we've written everything down, and now when the results are when this is asynchronously confirmed that everything has been deleted, we then write data to the database. So we're demonstrating how to do dependent calls using the Reactive API, right? So now we've got something very simple. I want to build a service to work with our data set here, right? So I can imagine a couple of useful methods. Let's say we want to have a class called the FluxFlix service, and our FluxFlix service will have a method to return a single movie by its ID. So we'll say by ID, passing in the string ID. That sounds reasonable. We might want to have an endpoint that returns all of the movies, right? So movie all, that's fine as well. And I want to have another endpoint that returns all of the instances when people stream when they stream a video, when they watch a video, right? And I don't actually have a giant catalog of users logging into videos, watching things on my website to work with here. So I'm going to have to sort of fake it a little bit here. I'm going to create an endpoint that returns a flux of movie events showing me whenever somebody's watched a video, right? So I'm going to stream, basically I want to stream a potentially unlimited amount of data relating to the streaming of data. So I'm going to stream the streams, or in essence, I'm going to cross the streams, right? So stream streams. And I'm going to create a little Pojo here just to wrap my movie. And the Pojo is going to carry the movie itself. It's going to have the date when this happened, and it'll have the user that's watching it. So there we go, right? There we are. And I'll use Lombok to make short work of creating the getters and the setters and all that stuff, and I'll create a toString method. There we are. So we have an all-args constructor and a no-argument constructor. Very good. So there's our simple DTO, or little Pojo. We can implement most of these pretty simply, right? So we can say movie repository dot find all. Thank you very much. That worked as we expected. Movie repository dot find one. Right? Again, this works as we expect. So there's this. But this one is going to be a little bit more interesting, a little bit more involved. We need to create two fluxes. We want to actually synthesize data that comes back at a trickle as things are happening asynchronously. So I want to use some operators here. We're going to create two fluxes, and then we're going to combine them. We're going to compose them. And that's really one of the benefits of this programming model here. By using the Reactive Streams API, and by working in terms of the Reactive project's primitives, Mono and Flux, you can write code that is easy to compose. You can write code that can be made parallelizable, right? You get that for free just by writing code. If you think about the Flux, my friend James here in the front, James Stratton, he gave me a very good way to think about it. He says it's sort of like an iterator, but it's inside out. Instead of asking for a new result, you get a new result. If you write all of your code in that way, it doesn't matter if right now everything is synchronous. Later on, you can switch it to become asynchronous, and the code doesn't have to change because it's in the right approach anyway. So what I want to do here is I want to say, let's create a flux that generates a new value. It publishes a new value every 1 second. Okay? So we'll say that that's a flux of longs. That's going to publish a new value every 1 second. There's a scheduler behind the scenes here. And then, since I don't actually have actual people watching movies, I'm going to just create some movie events, right? So I'll say events equals, and I'm going to create a new flux from a Java 8 stream. So I'm going to say stream.generate, and it's asking me for a supplier. And in the supplier, I'm just going to return a new movie event, passing in the movie itself, right? This is the movie itself. And then I want to return when, so I'll just say right now, sure. And then we need a random user, right? So I'll create a new method that returns the user for me. There we are. And same idea as before. I want to say string users equals, and let's see, MK Heck, that's him. J Strachan. Philip Webb, is it? I always forget his Twitter handle. Phil Webb, maybe. Yeah, I'm Starbucks man. There you go. There's just a bunch of users, okay? Java F expert. Okay, split. Go through that, and we're going to say new random and next int and users dot length. And we're going to say we want to index it by that random. There we go. So we'll now have some random users associated with those events. And what we want to do is combine them. So we want to actually emit a new movie event for every 1 second, or every time there's a new duration value emitted, we want to also emit a movie event. So we're going to use some of the operators in the Flux API, flux.zip in this case. And here I'm going to say zip the interval and zip the events, and then map them. I want to take the value, which is coming back as a tuple of two, right? Two values. I want to take it and tuple 2, x equals, get t2, right? Thank you. Tuple 2 of that, right? So what I'm doing is I'm saying create a new flux that contains only this new value, but produce this new value, the second value in the tuple, only when the first flux produces the value. So it's a zip. It's just like a zipper. It takes one from left, one from the right, takes one from the left, and then it produces a result. So there we go. We have a very, very simple API. Let's actually build a REST API for this, okay? And this is where, this is, I think, where a lot of people get a lot of value here. Is when you talk about reactive programming and you talk about it as an end-to-end thing, right? From the web tier all the way down to the data tier. And this is built in inside of Spring 5. We have a new web runtime called Spring Web Flux. It's another module that sits next to Spring MVC. It's not Spring MVC, but it should be very familiar for those who are already using Spring MVC. It works on top of the servlet API if you want it to, but for me and for my money, the most valuable part of that API is something that's based on the Netty sort of asynchronous I/O runtime, right? It's a completely separate runtime. It doesn't have anything to do with the servlet API. And that's what we have by default configured here. So let's build a movie REST controller. We'll say at REST controller. This is the sort of traditional way that we're used to thinking about building these endpoints, right? Oops, here we are, got that. And what I want to do is I want to inject that Flux service. Okay, create a constructor. And I'm going to create a few endpoints here that are going to be served up as web endpoints. So mono of movie by ID, taking a string ID. Okay, we'll come back to this implementation in a second. We're going to have public flux of movie, all the movies. Okay, return null for now. And we're going to create a public flux of movie events, string, the movie ID. Okay, now let's get rid of these first two. They should be fairly straightforward, right? So get mappings. Let's map the whole controller to /movies. So request mapping /movies. And then down here, we're going to say that we want to get a new movie by its ID. Should be fairly straightforward if you know about Spring MVC, right? So this dot by ID, code writes itself, okay? And then same thing for here, except that we're just going to get all of them. Don't need to specify the ID. Flux service dot all, voila, okay? Now this one is a little bit more involved. Think about what we're trying to do here. We're going to return all of the records, all of the events relating to a particular movie. That data may come back at different times. So there's a few ways in the web tier to handle this kind of sort of directionality. We're sending data to the client at unknown intervals. It's not something that we expect the client to load all at once. It's something that the client should know to constantly to be on the lookout for. It shouldn't try and close the socket or anything like that. There's a couple ways to do this. If you want bidirectional communication, WebSockets are a great fit here, right? WebSockets give you the ability to asynchronously deliver values to the client, to push values down to the client. In our case, we don't really need bidirectionality. We want to push data down to the client and just have the client, read it when it's available. And so in this case, we can use server send events. Okay, so I'm going to say value equals, and we're going to produce an endpoint that is of type text event stream value. And I'll map this to an ID. So what I'm going to do is I'm going to say return, or I'm going to say flux service by ID, passing in the ID. Then I'm going to take the results from that, right? I'm going to take that result, and I'm going to flat map that shit, right? So I'm going to take that result and return it. That's what the cool kids say. Isn't that true? Thank you, James. So FluxFlux_service.byId, passing in movie.getID. We want to stream, rather. OK, there we are. And there we go. So that can be a Lambda. So what that's going to do is I've demonstrated here a dependent call. We're going to asynchronously call the getById method, and then on the results, when the results come back, we're going to call the streams method on that, and then return the result of that to the client on this. Now this should give us a very simple endpoint here. Okay. Let's try this. Curl HTTP localhost 8,000 events. And you can see you've got a bunch of ID. Well, actually, let's just try events first of all. Movies, rather. 80. OK. A little hard to read, so we'll pass that to JSON PP and get us an ID. So let's now curl HTTP localhost 80/movies. Get that. Good. So that seems to be working. Now let's see if we can get the service end event stream that should produce a new value. There it is. Every second, we get a new value automatically being produced for us. Now, if you're using Spring MVC proper, the sort of classic approach to doing this, the traditional way of doing this, what you get back is what you would do is you return an SEC emitter, and then whenever you have a new value, you have to publish the value into the SEC emitter. So you're basically doing all the gymnastics that you would have to do when you're using a publisher. You're doing the same thing. It's just a lot more convoluted. It's more natural in the Reactive API to do that now. OK, so this is the traditional way of building web endpoints in Spring, and I think this is going to be very familiar to a lot of people. But there's a new approach called functional reactive endpoints that are supported in Spring 5 as well. So let's try that again. Let's revisit our same code. We're going to create a new bean here, router function, right? Routes. Good. And we're going to say router function dot route, and it's expecting and that of course can be a static import. So I'm going to say route, and it's expecting a request predicate. So we can say request predicate dot get, and the first thing that we need to do is to say I want to get all the movies, and then it's expecting a handler, and the handler is a callback. It's a Lambda. So we can put the code here. We can say when a request comes in, dot body to flux, right? Movie.class. And that should, let me see. Oh, movie.class, is that right? We want to call the FluxFlux service, passing that in, service dot all of them, passing that. OK. And this is what it is. OK. Request. Oh, service. Oh, sorry. Server response dot OK dot body service all equals that. OK, there we go. So I'm saying create. Let's see. There we go. A little cleaner. So I'm saying when the request comes in, I'm going to use the server response static import methods to create a response. I'm going to create the body, and I'm going to map them to a type of movie, right? That's the first route. I'm going to create another route. I'm going to say that I want to support. Did I not do that? Static method. Good. I'm going to say use get movies ID. Okay. And when this happens, we're going to return another Lambda. We're going to give it another Lambda, saying request comes in, OK, body, and here we want to say by ID. So we want to do the same kind of thing as we did before, where we take the results and asynchronously respond to them, reactively return the results. So service dot by ID, and we're going to say request dot path variable ID. Then we flat map that, send it to the response, and the response will be service dot streams movie by ID. Okay, movie by ID dot get ID. And I'm going to send more movies back, right? Oh no, this is the, just moving, oh sorry, moving just one by its ID. There we go. So there's this. Okay. Service by ID dot body. And that should be path variable. Looks fine to me. And one more route, we need to say movies ID events, where events is spelled correctly in some alternate world. And then we say that when a request comes in, request, I want to say OK dot content type, again specifying the content type here, text event stream, okay, dot body, and here we're going to do the same thing as we did before. We're going to actually do what I was trying to do very clumsily above, which is to get the result and then turn that into something we can use. So request path variable ID flat map. We're going to get a movie, and then we return the service dot stream streams, passing an M. Okay. So I want to pass that into movie event dot class. I'll turn it into a movie event dot class. This, of course, can be a lambda. And there we are. Okay. So there's our reactive code. Got the extra call there. So that's a little, it takes a few seconds for the eyes to parse all that, I think. You can extract all these callbacks to methods that return request handler. And then as long as, those can just be method references, right? I don't have to do them in line. But I think with that, we can go ahead and start it up and see what happens. Okay. So curl movies. Oops. Okay. JSON PP. Good. Silence of the lambdas is appropriately a horror. So we'll get that. Localhost 8080 movies. That one. Events. Fingers crossed. Hey, there we go. Good stuff. So now, two different ways of solving the same problem. You can choose the approach that you want. I think the functional reactive endpoints are really nice. They sort of map this functional style that we're trying to get when we go to reactive programming into using the Java 8s and Java 8 streams and so on. Now, this wouldn't be much of a service if I didn't have a client. So let's build a client to talk to it. I'll go back to Spring Initializer here, and I'm going to use Spring Boot 2.0. And I'll use the reactive web support. And I'll call this the Flix client. Okay. And we'll use Lombok as well, because I'm going to, no doubt, copy those types. And all I want to do in this example is just to grab the results and then write them out to the console. And again, we've got a service and event-based thing coming back from the client. One thing that what we're going to do is we're going to use an analog to the Spring Framework REST template in the new reactive world. It's called the Webb client. In the Spring MVC world, it's not super easy to use the REST template to do service and events, right? Because a lot of the things that we do in the REST template are to call an endpoint, wait for the whole thing, and then turn that whole thing into a result and then send it back to you to process. Well, imagine how that works if you've got a JSON structure that is never ending. You're sending back a million rows or a billion rows, a seemingly endless amount of data. You can't wait for the whole document to load before you can convert it. You have to convert it piecemeal. So a lot of the plumbing that we've had to do underneath the hood to make this work for you is to handle that kind of use case. How do we do message framing for documents or like that? Okay, so let's see. Here's our client. I'm going to start this up on a separate port, 8010, whatever. And what I want to do is I want to create a bean of type web client. This is our web client that we'll use. You can specify a root prefix, a root URL if you want, so localhost 8080, for example, movies, to make things easier. And what we're going to do is we're going to create a simple client to call that endpoint that we just created. So we'll inject this here, the web client rather. Return args. Okay, very good. Now, the client endpoint, the client method, allows us to say client.get, passing in the URI. In this case, we don't need to pass anything. It's just quote, quote, because we're calling the movies endpoint. We're going to get the results by calling the exchange method. And then it's our job to take the result that comes back. What we have is a client response. We need to turn that client response into something that we can use. So I'm going to say body to flux, and I'm going to take the types, the DTO, the movie DTO from our service here. I'll put that in my code base. And I want to do the same thing for the movie event. Here's this. Paste that in here as well. We don't have Spring data anymore. This is just a client-side representation. So Wiedersehen, little annotations. Okay, there's that. And now movie.class, that should give us the results that we can use. Once we have the response as a flux of movie, what I want to do is I want to find the first one that has that has a title, and this title could be what? What's a good title? Silence of the Lambdas. Sure. 2 lowercase, just to make sure I didn't screw up anything here. Contains, again, just to be sure. Okay, so that'll be we're going to find that movie by its title. And then we want to say, once we have, sorry? Dope. Thank you, kind stranger. So once we've done that, what do we want to do? We want to map that, right? We have a movie, actually. We don't need to, we want to map that? Why not? Yeah, movie. And then we say client response dot, sorry, we're going to say client dot get dot URI /ID /events, passing in the ID, in this case movie.getID. And we're going to say exchange dot subscribe system out print line. I'll buy that. Curiouser and curiouser. Okay, I think that'll work. Takes a second to parse. Not quite, huh? What do we have here? Client.get.uri ID events, passing in that. I got it there. Yeah. Sorry, subscribe. Did I already do that? Oh, right. Exchange map CR to CR body to flux of movie event dot class, and then we want to call subscribe again. This time passing in print line. Okay. Uh-oh. Filter for each. In times like this, there's no shame in copying your own code. So what we're going to do is we're going to go here, grab the client, source main, Java, com. Okay. I'm doing something silly that should have worked but doesn't. Let's see what we did wrong here, friends. So here's the new one. There's the old one. This assumes that configuration. So what we're saying is call the endpoint movies, make the request, map the request, the response to a collection of movies, filter the movies based on the presence of the name flux, which should get us several results. I think I just did something with the equals there. Then we said subscribe to the movie. Then for the movie that we get back, we call this endpoint. So what I did differently here was, I should have called subscribe. filter. Doesn't really matter. We have this here. Okay, there we go. So with that, my friends, we have very briefly looked at some of the things you can do in the Spring 5 stack to support sort of asynchronous I/O, both on the server side as well as on the client. We've looked at how to connect data to your endpoints. Again, the benefit here is that through the whole request chain, it's all reactive. The client takes a request, it puts it it takes a request and it frees up the front end web thread pool so that the web server can actually respond to more requests. The result is then sent down to the database driver. The database driver itself keeps a file descriptor ultimately that sends an event when there is data available and no sooner. At no point do we have threads sitting around waiting for responses. And the nice thing about this is that it's all the way through, right? The request all the way down to the kernel. You get the ability to scale here. You can use less threads in your code, in your application, right? You get to scale your services more readily. So there's a lot of power here, but you don't have to give up all that you know in order to be able to make this move. You have the full power of the Spring ecosystem. Now, what we have here is preliminary. Spring 5 will be released this summer, along with a complement of other features. And then you'll see Spring Boot follow on later this year with the sort of auto-configured version of this. In order to make this work, of course, we're supporting and integrating reactivity inside of Spring Security. You're going to see it inside of other technologies where it makes sense as well. So with that, my friends, thank you very much for your time. If you have questions, I'm happy to take them. Thank you very much. Cheers. Questions? Yes, sir.
So I saw how you deal with NoSQL repositories, but how do you deal with repositories that address relational databases? Because in my experience, relational databases means a word of synchronous thing.
Yes. So the question is, how do I do JDBC asynchronously? And the answer right now is you can't, because it's intrinsically not asynchronous. It's not reactive, rather. You can do asynchronous JDBC, but that's not what you want here. Oracle, again, to their credit, in the last Java 1 in 2016, several months ago, they actually talked about, in theory, supporting JDBC, reactive JDBC. I don't know what that means in terms of concrete plans, but if Oracle gets it, then that makes me think it's probably established enough concern that it's going to happen. So, sorry. We'll support it when it's real at the JDBC level. Right now, there are certain databases like Postgres which have a pseudo-reactive API that's separate from their main one. It's not JDBC. It's just, it's not quite there yet. Other questions? Yeah, we can support HTTP2 on the service. I'm pretty sure we can support HTTP2 on the client as well. Yeah, I know that the server side does. Right. Service and events. This is separate from HTTP2. Yeah, sorry, yeah. I'm blinded up here, my friend, I'm sorry.
Does it support back pressure?
Yes, so the question is, does it support back pressure? The Reactive project, which provides the publisher specializations, Mono and Flux, provide all those operators, it supports things like back pressure. It has the ability to say, instead of consuming the next message, I want to stop consuming until I'm able to handle it. Right? So one of the benefits of moving to reactive I/O is that it's very similar to working with messaging technologies like RabbitMQ or ActiveMQ or whatever. With a message queue, you can never overwhelm the message queue. You can send as many messages as you want, or rather, you can never overwhelm the consumer, the message consumer. Same thing here. I can send as many messages as I want, but unless the consumer is asking for new messages, it's not going to be overwhelmed, right? It's not going to overwhelm itself. It'll handle whatever it can, and then not taking delivery of any new messages. So that's an operator on the Flux or the Mono or the public, those types there. Yes, sir.
How would you deal with transactional scope, rollbacks?
Oh, transactions. So when we talk about transactions in the Java world specifically, we're talking about JTA. We're talking about distributed transactions, right? Is that what you're talking about? If you're talking about resource local transactions, then that is a discussion to have with each of the technologies involved in the pipeline here. If you're talking about distributed transactions, there's no great answer. Distributed transactions are supported by the X-Open protocol. The X-Open protocol, there's client-side middleware binding for that called JTA in the Java platform. The JTA support transactions, and JTA ultimately rely on all sorts of thread locals and magic and stuff. So that's not going to be a great fit in your reactive world, right?
So would the error go in the error channel, or what?
Yeah, there's actually an error callback. There's actually, in the subscribe method, for example, there's an error consumer that will take any exceptions there. So I said subscribe, and then it says a consumer for the item in the stream or in the item in the publisher. There's another lambda that it expects for the error, so it'll throw back, it'll give you any exceptions in that lambda. And then the third one was the runnable for the on termination, when it's done subscribing to records. Yes, sir?
Does Spring 5 have a flux for JMS message consumers?
Not yet. The question is, does Spring 5 support fluxes for JMS? And I know we have work being done in Spring integration, right? Spring integration is going to support reactive consumption wherever possible. So, but not yet. Other questions? I can barely see, so if you're out there and I'm not selecting you, throw it up. All right, well, thank you very much. I'm around. Feel free to ping me if you can. Cheers.